Hey y'all, welcome back to eCoreAcademy. I'm Tania, and I'm back with our lesson on parallel and perpendicular lines. There are two parts to this lesson, and the first part is mainly just a lecture video, while the second part is more of an interactive lesson where we will be going through different types of problems and solving them. But without further ado, let's get into today's lesson. So you may be wondering, Tania, what even are parallel lines? And parallel lines are just lines that will never intersect on a coordinate plane. They have the same slope, and that just means that the end value of both of their linear equations are equal to one another. Sometimes there will be situations where both slopes equal 0 or undefined. And even though they're not necessarily normal numbers, I'd say, there are still parallel lines. Why are they parallel? That is because they're still straight lines that don't and will never intersect when graphed. They both have the same slope, which will be either 0 or undefined. For example, over here, the slope of these four lines are 0, and therefore all four lines are still parallel to one another because they all have the same slope. But over here, the slope of these two lines are undefined. And because they're the same slope, undefined, they are still parallel to one another. Then there are the other type of lines called perpendicular lines. Perpendicular lines are lines that intersect on a coordinate plane at a right angle. They have slopes that are negative opposite reciprocals, and what that essentially means is that when there are two lines that intersect with one another, and those two lines are perpendicular, each of those lines has its own linear equation, and obviously the linear equation has an m value of that line. When both of those m values are multiplied to one another, the product of that equation would be -1. Here is an example. On this coordinate plane, there are two lines, the red line and the blue line. These lines are perpendicular, but why are they perpendicular is the question. Well, number one, they're intersecting at a right angle. But as you can see, there's no notation to kind of assure you for that. Therefore, you have to look at the slopes of each equation, and that should be your first resort. They both have a slope that when multiplied, they will equal -1 together, because the slopes are negative opposite reciprocals of one another. You know that it also creates a right angle because you know that it's a perpendicular line, but you always want to make sure that sometimes it's not drawn to scale, and therefore you always want to take the safe way out, which would be something that ensures you of it. Sometimes the slopes equal 0 or undefined. So what if that is the case? When one of the two perpendicular lines have a slope equal to 0, the other one will be undefined. And that's the only way that you'll know that it is the lines are perpendicular. Why are they perpendicular? It's because though no math can be done with an undefined number in the equation, the two lines still intersect at a right angle when graphed. And here is an example of that. So this line over here, line A, has the slope of undefined, while this line B, has the slope of 0. They're both graphed, and though we do not have an equation to go by, this notation of it telling us that there is a right angle over here kind of assures us that there is a right angle being formed, and therefore these two lines are perpendicular. And we can figure out the slopes just by using our skills of finding out the equations of graphed lines. So in this example and this picture over here, we're going to figure out which lines are which. I want you guys to name one pair of parallel lines and one pair of perpendicular lines. And I want you guys to throw them down in the comments below and also explain and give me a reason of why that one line or that one pair is parallel and why the other pair is perpendicular. I'm going to give you guys a second, but pause the video if more time is needed. So pause the video if needed. But one pair of parallel lines in this picture over here would be f of x and j of x. And I know that because one, I already see that they're not intersecting, at least here. But what if the picture is tricking me? I need something that really does assure that they are parallel to me. Parallel. And that would be looking at their slopes. Looking at the slopes of each individual line, you know that this line slope is 2 and this line slope is 2 as well. And when both slopes are equal to one another, that means the lines are parallel. But now let's look at perpendicular lines. This is kind of where I was talking about, where you kind of might get tricked. So, as you can see, h of x and g of x are definitely perpendicular, but it doesn't necessarily seem like that right away. You don't see that notation telling you it's a right angle. And even when I look close, actually, I don't really see that proper right angle being formed. But I know it's perpendicular because I'm looking at the slopes. And when I multiply the slopes of h of x and g of x, which is -2 and 1/2, I get -1. And we know that when the product of the perpendicular line's slopes equal -1, the lines are for sure and definitely perpendicular lines. That's kind of another great example where the triangle does kind of throw you off. Lastly, we're going to go with one more of these problems, which lines are which. I want you guys to comment them down below, name one pair of parallel lines and one pair of perpendicular lines, and why are they parallel or why are they perpendicular. I can give you another second, and then you guys can pause the video if more time is needed. But starting with the parallel pair, we already know that K and L are parallel. Here we don't have any numbers such as slopes to look at, and therefore you really have to look at the drawing itself, analyze it, and look at the notation. Something that you guys might want to take note of is that this symbol over here, where it looks like a greater than sign, it just says is this line is parallel to this line. It's as simple as that. If line K and line R were parallel to one another, there'd be two of the greater than signs here and here, just to say that these two are a pair of parallel lines. But they're obviously not parallel lines, and therefore there aren't any, but these two are, and therefore we do have that one greater than sign here that corresponds to the greater than sign over here, saying that K and L are both parallel lines. We know that they're parallel because they're never going to intersect. We know that by this notation over here, but also it is pretty clear in the drawing. But like I mentioned before, we never want to kind of just see it based off the drawing. We want to make sure that there is a reason we believe it, and in this case, it'd be the notation. But then there are more perpendicular lines. We actually have two pairs of perpendicular lines in this picture. We have the first pair, R and K, or the other pair, which is R and L. So if you guys commented one of those down below, you are still perfectly fine as long as you got one of them. R and K are perpendicular because we see that there's a right angle formed with these two lines. And this notation over here tells us that they're for sure perpendicular lines. R and L are in the same or have the same case. Those two lines also create a right angle, and we know that by this notation here, which ensures to us that these lines are also perpendicular. So that was kind of it for this rundown lecture video of parallel lines and perpendicular lines. I hope that was informational, and if you guys have any more questions, please don't forget to leave them down in the comments, and we'll get back to you at ASAP. This is our website link and our Gmail in case you need to reach out to us, and other social media platforms. There's also all the information down in our description box below, but please do not forget to like and subscribe to our channel and comment down below again if you guys have any questions, comments, or concerns. But until then, I'll see you next time. Have a great day, night, whatever time of the day it is.